In part two of this lecture, we're going to be talking about scientific evaluation. And again, the idea is to use the scientific principles to evaluate an environmental project. And that project could be something that was completed or something that's ongoing, but to take these same ideas of science and apply them to evaluation. And we're going to do that and also look at some of the examples we've had in the course and how we could evaluate them. So the scientific evaluation, we want to address how to make scientific decisions that include the uncertainty, the control, and the range of values. And the one way to put that right out in front is to look at these range of values as being, what are the values that people hold and aren't going to change, and what are the values that they might change if they were presented with certain information, and what information would they need. So right there we're talking about different types of values and the relationship of values to information. So that's a step forward. The other thing is, by using a scientific approach, we would try to make objective statements that can be verified by somebody else. So for example, if I said, in this situation, in this community around the lake, 20% of the people were really environmentalists and 80% of the people were cornucopian individualists, other surveys could identify that, but that would really lay a landscape for possible value disputes and also for possible political solutions. Another part of scientific approach is to use rigorous and transparent methodologies. That is, that the methodology can be checked for the type of results it gives, and also we're looking for discovering new knowledge, not just making a one-shot judgment or a one-shot final answer. We're trying to say we're discovering new knowledge, and that knowledge is being used by individuals in the community. So the key problem, just like we saw with how scientists are involved in environmental problems, is how do we treat those values objectively? And the way we can do that is by setting up a process. And I'm going to outline this process briefly here, and then we're going to look at some of the examples that we saw in class related to this process. So to highlight that. So let me just go through this quickly, and then we'll come back to that. So the first is, do we have a value statement that is really clear enough for the entire community to understand? Have we stated it in a way that they understand what the benefit of improving the environment is? And then when we talk about background and introductory information, we want to collect narratives from people, and we want to go out and look for a wide variety of plausible scenarios for the future. We don't want to just collect. We don't want to start with our answer and then make one on either side that are, one's too hot, one's too cold, the sort of Goldilocks scenarios. We need to really look for reasonable scenarios. Then for goals, again, sort of like the value statement, are these stated clearly enough that they bring in the issues, the real issues, and that those are made clear enough? The next two are sort of technical. We want the objective to be stated as hypotheses so that we can check whether we met the objectives in a scientific manner. And the budget often goes along with that. Was the budget sufficient enough to actually let us meet those objectives, to do the range of measurements and the extent of study that's needed? Okay, the final three are really where the most judgment comes in. And when we have new knowledge that was created, were people using that? And did the community learn how to handle the situation? And so, for example, if I publish a paper in some obscure journal and it sits in a library and no one reads it, that's a scholarly contribution that goes to create the overall value that we derive from science. But if I make a report directly to a client or to an agency that has to make a decision, and they use that right away, in one case we know that the knowledge was applied and used. The other way we don't really know. So there's there's newer techniques now where we use modeling, and the model would have immediate feedback. People would be able to see, did they use the model? How might they change it? What parameters they use? Then we're actually in the process of using that model to make decisions about water quality or forest use. We're actually getting feedback. We're seeing people using it and how they're modifying it. And the final two, again, we haven't really addressed much in this class, but they're very important. I mean, specifically, but they're a very important concept. One is the adaptation. Did the overall project demonstrate how it was going to use this new knowledge to change? And again, this is a very tough issue for a lot of agencies. They have a mission. The mission is determined by the larger government. They're given that mission. They don't really get to adapt to their mission to fit individual circumstances. And so it might be a change in the process by which they handle these situations that we're really looking at. And finally, sustainability. Although this is a major topic and it's been threaded through the course, we haven't really seen any very specific examples about how we establish sustainability. So let's look at a few examples just from the class, and this is the last thing I want to do, just sort of summarize how we've been, some of the tools that we've talked about in class and some of the concepts. So for example, value statement. In week 6 we talk about genuine progress indicator. This would be a really good way to lay out the values that include education, science, economics, and socioeconomics of any particular problem. Lay it out using that genuine progress indicator approach would really help set up how the problem is being defined from the first to include all these different parameters. The background and introductory information, that's obviously scenarios. In week 8, we talk about collecting the information and making scenarios and using the scenarios as a way to scan that we actually went out and found fairly reasonable explanations from different worldviews. And that leads right into the goals. In week 9, we used worldviews really to scan and bring in a whole range of different values that otherwise we might miss if we just started from one sort of type of solution or previous solutions and just try to adapt it. Instead, looking for all these different worldviews. And the way I did this, again, in Klamath Lake, my work down there is like get some artist rendering of that so it becomes very sort of concrete and they can see what it might look like, how these different scenarios might play out. Okay, the objectives, we saw a couple good examples of this. In week 2, we talked about how poverty might be related to malaria and be related to environmental conditions. And by making a systems model of how poverty relates to economic development and how that might relate to malaria, and then how malaria relates to environmental conditions such as rainfall and, say, potholes and swampy areas. Those are environmental conditions. That model then can be used as testable hypothesis that if we are expecting certain rain in an area and then we clean up those potholes and ditches and swampy areas, get them to be drain better, then we should see less malaria, we should see more increase in the workforce, and we should see a better, healthier public, which then can lead to a more healthy economy. So that's an example of tying those things together, even with a conceptual model. Instead of just saying, well, we need to clean up malaria because we think we should, you link it to these other impacts, and you see, well, what if you do the environmental treatment, reduce malaria, increased economic growth? So that's just an example of how you might state these management activities as hypothesis for what, if you do this, then you would expect something to happen. We also saw that with the Willamette Valley placement of different land use options in the Willamette Valley by playing with the placement of different parcels, how different land was used, see either optimizing more for economic development or more for species protection. And you could really sort of play with those options to see that you would hypothesize that having forests next to conservation area next to agriculture is better than having agriculture and forests separated from conservation areas by urban areas. So this combination, and again, that's the underlying hypothesis of how putting things in the right place has a better outcome than just scattering it around. So those are examples of using models and to make hypotheses for management activities. Now, technical specifications, this is really where we saw the use of environmental accounting. So for example, we wanted to find out how we get the best outcome for minimizing the water use for diapers. We accounted for the hydrologic cycle, we accounted for different places the cotton was grown, we accounted for different types of washing. All of those things, we're really looking at sort of the technical details using that life cycle analysis. And sort of a study that wasn't quite so clear about that was in week 6 we talked about the ecosystem services and the Lentz district, where we had a certain amount of damage that was done by floods, and then in order to balance the cost of the project, the rest was made up in ecosystem services. So that the methodology was there, the numbers were there, but it would really be good to go through and see, using a process like this, can we actually justify that amount of ecosystem services as a financial number, as a financial value coming out of that ecosystem service project? Is that really justifiable or not? So using a project of evaluation, you could go through and do that. And then things like budget, we didn't really address that at all in the class. We didn't really talk about anything where we analyzed the budget. The new knowledge, again, we're talking about new knowledge actually being used by a community to make a decision. We saw more examples of this in ESM 101, where we had community conservation projects and how it was actually used. But in this class, ESM 102, we talked a little bit about this in week 9 when I brought up this idea of participatory modeling. Have a model, people can see what the expected outcomes are, including sort of ecological outcomes, sociological outcomes, economic outcomes. All that stuff's just right apparent by the way the model works. You change the parameters, you get a little different output. People can see how that works. This is, again, a contribution to new knowledge that can be useful in helping the community learn. And then 2 other areas here, adaptation and sustainability. Again, we didn't really address this very much in any specific way in the course, but you would have to have the rest of the evaluation done before getting to these points would even matter. But you can see that they're very important. How do you use the knowledge to make choices to move ahead? That's like what we talked about in scientific adaptive management today. And the final one, sustainability. This has been it's a theme of the course. It's a theme of what we do in our department and actually at Portland State. So it's sort of embedded in everything, and I think maybe in the future I'll try to call out a few specific examples of how these environmental projects really can be used in the context of identifying sustainable goals and meeting them. Well, that's it for this week. That means that's it for the course. So thank you very much. And now you have the content assignment and the crux assignment, and then during finals week there's the extra credit assignment if you choose to do that. So good luck with those.